recording on the screen? Yep, perfect, thank you. We said earlier that we're doing an additive inverse to create the additive identity, which is 0. So what are we trying to create here?
The multiple identity.
The multiplicative identity called a, what is the multiplicative identity, sorry? 1. Well, multiplication is repeated addition, but see, this is the thing as well. I have a couple students who are answering this. We should have taken notes and put it on our graphic organizer and reflected on it. This is numbers 1 and 2 from the Understanding Concepts of Linear Functions. We got to know this information. What's 1 times x squared?
X squared.
Right? Because that's the multiplicative identity. What's 3 times 3?
1.
9.
9.
Did I create a 1?
No.
No.
Yes.
How?
Did I?
No, you didn't. You created a 9.
I did not create a 1. So should I multiply by 1/3?
No. I multiplied by
3 over 1?
Say that one more time.
3 over 1.
Say that one more time.
3 divided by 1.
3 divided by 1.
Remember, and I'm saying that because I want you to remember, we need the multiplicative inverse is also called the, starts with an R, reciprocal, right? So that fraction switch, the numerator and denominator switch, and it's understood when it's x squared divided by 3 to be 1 times x squared divided by 3. That changes things. Notice, what's 3 divided by 3?
1.
Now I've created a 1. We got to pay attention to this. This is also why I don't want you to just show the inverses. You need to think through the identities. Did I create a 0 and did I create a 1? If you haven't created those things, then you're not approaching it correctly. So x squared is equal to?
6.
36. Well, 36.
Remember, x squared is equal to 36. Pay attention to what's there.
Okay, I got a question.
Yes, ma'am.
Okay, so I didn't do it like that, but I still got the same thing.
What did you do?
I did it like that, I just didn't put a 1 over it. I just knew to do 3.
That's fine.
That's okay?
Yeah.
Okay. Well then, yeah, I got it right.
Right. I mean, like, you're getting here because you still use a property of equality to create what kind of equations?
Maybe.
Hold on one second.
You said, say it one more time.
We used a property of equality to create what kind of equations? Equivalent, right? These look different, but they are still the same, right? Notice which property of equality do we use? A lot of us knew on the graphic organizer those properties of equality create equivalent equations, but how? Well, because whatever we multiplied by 3 on one side of the equation, and we had to multiply by 3 on the other side of the... Y'all, we're dead. What's going on here?
Other side of the equation.
I mean, yes, but like, I got 2-3 students that are answering questions. Eli,
I was trying to look.
come on, I need you to wake up. Desi, I need you to wake up. We got to be awake and in this conversation here. I cannot emphasize that enough. I heard Caleb talk a couple of times, but we all need to be involved in this conversation. The person who talks the most learns the most. That's one of the most plain things that there is. That's why I have you talking within small groups.
It's going to come up with the same value because it's equivalent.
Well, they are equivalent, but my point right now is just, hey, whenever I multiply by one side of the equation, I have to multiply by the other side of the equation. That's called the multiplicative property of equality. You got to know that, right? It's not just, it's, I think I wrote on a lot of your graphic organizers, okay, you told me why we use properties of equality, but how do we do it? Whatever I multiply on one side, I have to multiply on the other.
I got a question.
Whatever I add on one side,
You gotta add.
I got to add on the other. Yes, Anthony?
Okay. Ain't 3 over 1 the same thing as 3?
Yeah.
That's what I had asked.
That's what she asked earlier.
Because that's what I did. I didn't do over 1.
So why you don't do 1 over 3?
It's not how that works because 1 divided by
Because you said if you have a fraction, flip it and then multiply by it. You said flip it. But 3 over 1 is the same as 3.
Mm-hmm. You see how it's x squared divided by 3?
Oh.
X squared
Okay.
divided by 3, that's the same thing as 1/3 x squared.
Oh, okay. Okay.
Notice, again, we're dividing. The inverse of division is multiplication, so I'm multiplying by 3.
Okay.
Right?
Yep.
That's why we want to pay attention. Hey, it's 3 divided by 3 is creating a 1. Final step, like a lot of us got to here, I think, as well, and we got stalled out. What do I
Square
do?
root.
Square root of 36 is 6, because 6 times 6 is 36.
Okay, so I take the square root. You gotta pay attention to the inverses, because those inverses cancel out, creating zeros and ones. X does equal 6, but what else squared is equal to 36?
Negative 6.
Only one of us remembers 6 and negative 6. You gotta remember, and I've talked about this 3 or 4 times now, when you take a square root, how many answers are you gonna get?
2.
2. Every time. You gotta know that when you take a square root, you're gonna get 2 answers. A lot of us miss that detail, and I only see 5 or 6 of us writing that detail down. These are things that we can write in our notes so we can come back to them later. And I do want to point this out, not to pick on Kyle, but I can see his stuff right here. No. Kyle has the correct answer here. But did you ever write down why you got 6 and negative 6?
No.
Could that be important to understand why you're doing this? Not just to say, hey, I'm randomly getting 6 and negative 6. When I take a square root, I have to get both because both make the equation true.
True.
Right? Both a positive and a negative 6 are going to make that equation true. And that's true every time you take a square root. You got to explain why.
How you get 6 again?
Well, so one thing is, you can just put it in the calculator. Do you understand how I got 36? Okay, so when we have a square root, well, first let's go back to a square. What a square is telling me to repeatedly multiply, right? 6 squared is equal to 6 times 6. A square root is the inverse. So a square root is asking, hey, what was repeatedly multiplied to get that number? So what did I multiply by itself to get 36? What did I multiply? What was multiplied by itself to get 36?
6 squared?
Well, the 6 was multiplied by itself, right? So x is equal to 6.
But when I put the square root of 36 in the calculator, I can get something.
What'd you get?
Did you press square
Check it
root
again.
first and
Take
then
the
put it in
square
there?
root, because you should get 6.
Control and then hit the
X squared?
The x squared and then put the 36 in there.
Yeah. Did you get it now? So remember, what a square root is asking is, what was multiplied by itself, right? Because a square root is the inverse of the square. Well, 6 was multiplied by itself. The same thing is true that negative 6 times negative 6 gives me 36, which is why we get 2 answers. Every time you take a square root, your calculator is only going to give you a positive. You need to know it's positive and negative. Okay. Any questions about that before we move on? Okay, for the next one, 4x plus 3.
We got another one? Oh, dang, I didn't even see that one.
4/3 x minus 5. Okay, let's look at these. What's the first thing that we need to answer before we start working on this problem?
How much is it going by? Yeah.
The rate of change is part of it, and also the rate of change tells us what type of
Equation.
Linear
function, which is then the type of equation. You got to identify that first. Remember that rate of change is defining the function. So what do we see happening here?
Well, yeah.
Is that the only thing happening? Because I saw a lot of people with a slope before.
On the other side.
Oh, I need to look at both sides?
Yeah. Because it's the x and the y.
We got to look at both sides, the x and the y. Come on, if we're adding repeatedly on both sides, what type of function are we talking about? Bro, are you even trying, or are you just trying to get me to stop talking to you? Come on, take the hood off. Get your mouth out of your hood, get your notes out, pay attention. We got to do something. You can't just sit there.
I thought you was subtracting by 4. No, you're going to be adding because it's going to positive. It's going from negative to positive.
So remember, negative 9 is here, negative 5 is here. If I'm going to the right, am I adding or subtracting?
Because the positive is going to be on the other side of the line. So you add it.
Anytime you're moving to the right, it's adding. And you can also think about this because we're talking about a graph, right? -3, -9 would be here, roughly. 0, -5 would be here. Not quite there, but maybe here. You see how it's going up? Going up is adding. Does that make sense?
What you get?
And so, what you're probably thinking about, okay, are you the one that asked this? Okay, what you're probably thinking about is, if it was a +9, and I went to a +5, I would subtract.
It might be swap.
But we're not talking about positive numbers, we're talking about negative numbers.
-4. The y-intercept is
Okay.
-5.
So I just did it.
So, can anyone help Kiwan out and tell us what type of function repeatedly adds?
Linear.
Linear. You gotta know that, Kiwan. That's gotta be something that comes right off top of our head. Alright? Linear. And we know, and since it's linear, we know that the equation is the equation.
Is a y equals mx plus b or a plus bx?
Either one, right? A lot of us notice that. Ishmael, how do we calculate slope? A lot of us told me on the graphic organizer that slope is the additive rate of change, and that is correct, but there's more to it than just that. You gotta know how we calculate slope.
Rate of y, change of y
Change in y,
over change of x.
say that one more time.
I mean, change of y divided by change of x.
Okay, Ishmael, did you see another way that we identified slope in our notes? What does that say right there? On a graph, yeah, but remember, m equals that. Rise divided by run. Either way, you want to talk about it.
And then
Yeah.
So we should add a fraction for our slope.
Dang. I only had the 3. I didn't have the 4.
That's kind of important though, right? Change in y divided by change in x.
so it's f of x
So what is b?
-5.
Why is b -5?
Because it crosses the y-axis. It's on the
You don't have a
y-axis.
graph.
Because it's on the y-axis.
But do you have a graph to talk about the y-axis?
Is it?
Because I
What did Eli say? Eli, what'd you say?
The x value is 0.
The x value is 0.
So that's why it'll be the plus b part, because it got a 0 with it.
So
Yeah,
remember,
it'll be on
if you're on the y-axis, what is the x value always?
0.
0. Does
Okay.
anyone know what specific problem? We spent a ton of time talking about these exact ideas.
The table on the worksheet we just did, before the second one we just got, linear
Understanding concepts, linear functions, number
5.
5. We defined everything there. If you don't have that in your notes to go and study, or use it on bell ringers, or use it on your homework, then you need to go watch the videos or come into tutoring. Number 5, we spent a ton of time on that specific problem. You gotta know how to calculate slope. You gotta know how to identify the fact that it's linear, how to calculate slope and identify the y-intercept. Listen, I want you to be successful to the utmost degree. And I know some of us are looking at me right now like, Mr. Kenny, you're expecting too much.
Mr. Kenny, why?
Fam, 8th grade math that you did again in Algebra 1, and I know COVID hit some of us hard. And I know it's been a minute, but at a certain point, you got to make the decision, say, hey, I'm going to be awake in class, right, Eli? Thank you, sir. Eyes open. You got to make the decision, say, I'm going to look at this stuff on my own time to make sure when I come into class, I'm ready to talk about it. Some of us, it's going to stick really well immediately. Others, you're going to have to take time to study. I had friends that never had to study in a single English class because it just stuck. That's how I was with math. But when it came to English, I had to look at that crap almost every single day, otherwise I was going to forget it. You got to know what your strengths and your weaknesses are. If your weakness right now is math, you can't hide from it. You got to put in the time and effort to learn, because hard work pays off. If you learn nothing else from my class, I hope you learned that hard work pays off. You got to put in the time and effort. I want you to be successful. But you're going to have to actually learn for me to be successful. Alright? Any questions before we continue? Going once? Yes, sir.
I'm not gonna lie, this class is kinda hard. I mean, you teaching everybody a lot, everybody understand it, like, some people learn differently. I never took algebra, and I'm in algebra 2.
You never took algebra 1?
No, I wasn't in none of these grades except for 8th grade, and I ain't took algebra either.
You didn't do it online?
No.
That's a problem. Not like you did something wrong, but I need to talk to someone to get that fixed. Because you should have taken algebra 1.
So what you been taking?
I took geometry, I didn't take algebra.
I took algebra 1A, 1B, geometry.
And then algebra 2.
Yeah.
Okay. And I get that. I had some of y'all for algebra 1A. And Gerald, I agree that my class is somewhat hard, but the reason why is because I care about you. I need y'all to understand.
Now, notes and everything, but I don't know right now.
Yeah, algebra 1A.
So then-
And the algebra 1B.
Have you studied your notes or watched the videos or come into tutoring to understand it better?
I tried, but I gave up after like 2 videos.
You gave up. Like
At least
you
you
gotta
realize-
realize like you gotta put in the effort. Like I appreciate the fact that you started, but here's the thing, like and the student who came in for tutoring yesterday, they said the videos were too much. Guys, you don't have to watch all the videos. I identify specific parts that you should be looking at based on what you're struggling with. When I upload this video, I will make the notes on there tonight that, hey, minutes like 1 to 7, we talked about solving quadratic equations. 7 to whatever we're at now, we talked about writing the equation of a linear function. If you know you're struggling with writing the equation of a linear function, then you need to watch this. Or I would go look at number 5 from Understanding Concepts of Linear Functions, where we really broke all this down. Because all it is starting at the beginning. What's the first thing we got to identify?
What type of function it is?
And what determines what type of function it is?
What type of
The rate of change.
you got?
Gerald, all you got to do is identify the rate of change. Remember, what is the first thing that mathematicians do?
Notice.
They notice,
Describe.
no, notice what? Patterns and relationships. Gerald, you got to notice that we're adding 4 every time to the y values. You got to notice that we're adding 3 every time. And if it's repeated addition, you got to know off the top of your head immediately that it's what type of function.
I mean, out of everything that I did, that's pretty much the whole thing I did was just put, I knew to add all that stuff.
Hey, why are you getting frustrated? Calm down.
I mean, no, I'm not getting frustrated. I don't really get asked to teach nothing like that. But that's what pretty much I did.
Okay.
That's all I got to.
But you aren't listening to the second part of it. You did this part, right?
Yeah, that's all I did.
I know. But once you know that you're repeatedly adding, what's the immediate thing you should know? Come on, we said it multiple times today. What type of function has repeated addition? Linear. The fact that you know it's linear, there's only one equation we've talked about so far. You got to know this equation. You got to know that if it's linear, y equals mx plus b. And then you got to know what m stands for. You got to know what b stands for. That's why I had y'all do the graphic organizers. If you haven't done that yet, or if you need to fix it, like do that. But like you got to know this stuff. All right. We'll talk more about this once I get everyone else started because we got to get going. But guys, if you are struggling and you're stuck, you can't sit there and get frustrated. You can't just say it'll get better. No, you got to do something to fix it. And I agree that some people learn different ways, but I'll also say this, some of us are struggling because we're not used to actually having to learn it well. We're used to a teacher breaking it down and telling us exactly what to do for every step of the way.
That's what I
That's
told
why I
him. That's
like
what I told
No,
him.
no. Back up. If you're saying that's how I learned it, no, that's how you did it, but do you remember it from 8th grade math? Are you still remembering it? So you didn't actually learn it. I need you to understand. I know that I'm tough, but that's because I'm going to ask you to actually understand without me having to tell you every step of the way. I know that it's easier, and so we think that we learned it. I know that we passed it, and we moved on learning it that way. But if you can't remember it now, did you actually learn it well?
No. That's how I was with my mama when we had first started, and you was like, we don't just cancel out the thing. And I told her that she was asking, well, why do you do it? And I was like, I didn't have an answer because I just knew that they said you always supposed to do it.
Right.
I just did it.
So I just did it. I need y'all to hear me on that. Like, I get it. I know the way I'm teaching is different, but I do it because I care about you and because I'm trying to fight for your best. First off, right, if we don't remember it, if we plan on going to college, this is the basics that you have to know. You got to. There's no ands, if, buts about it. There's no way around it. You've got to know how to do this. And if you couldn't do this on your own now, even after I taught you, that's problematic. And that's not to put you down or anything like that. It means it didn't stick. So we may have thought we learned it, but we didn't. All right? We've got to go back and reteach ourselves because we thought we understood, but we didn't fully, and it's affecting us now. All right? Please understand, I do this because I care and because we actually need to understand. You can't just expect someone to give you every single step along the way. You go to college, no college professor is going to say, hey, calculate my slope. And the slope is rise divided by run. And give me the y-intercept, now give me the equation. That's never going to happen. You have to understand and be able to put those things together. And if I let you go off to college without having thought through it and be able to do it on your own, that means I didn't care about you. That means that I was okay setting you up for failure, and I'm not.
So what are you trying to say?
I'm saying that I care a lot about you and that yes, I know it's difficult, but the best things that we can learn is how to overcome adversity. I'll give you all the support you need to be successful, but you gotta do what you gotta do to learn. We'll get some more practice in with this. I'm gonna change up what I was planning on doing. Actually, I guess before I change things up and move forward, what questions do you have? I know that we're going to get frustrated. I need you to understand. I know we're getting frustrated for some of us, but you have a small group to talk with to develop better understanding. You have videos online. You have tutoring 4 times a week. You can be successful. And if you work for me, if you actively collaborate, if you develop your understanding, you go home and you reflect on what you learned, you will be successful. In that you will learn long term, not just how to get through a test. Anthony, you had a question?
Alright, I got a question. Can we get like a worksheet and like with a whole different bunch of problems and we learn how to do that, how I learn how to do it, like more practice. Can we get more practice on it?
Let's talk about that. Let's go to Matthew. What your practice is, your daily practice assignment.
It's supposed to be due Sunday, and you gotta make the use
So,
the password. You log in.
Before we go to Matthew, we'll get the things out in a second. But
Yes, you do.
I need y'all to pay attention to this. Yes, ma'am.
What did it say that we're done when we finish the whole thing? I know what.
We'll talk about it in a second. I'll talk about it. I'll look at it in a second with y'all. So, yes, I can look to see if you've mastered the concepts, things like that. So, first off, I do want to talk about active collaboration and scoring rubric reminder, especially because we got our graphic organizers back. We're going to look at our objectives. I plan to do lesson 2, but we'll just have to work on that tomorrow. And what we're going to focus on is the Carnegie Learning Online Workspace called Mathia. So first off, I need y'all to understand this. This active collaboration rubric, once again, is built on the idea that you are talking and sharing ideas and thoughts and insights. The students who talk the most are learning the most, plainly put. I cannot force you to talk, but I am going to score you on your discussions within your small groups and within the whole class discussion. And you can see your scores online. I emailed you and your parents, as long as I had an email for your parents, but I emailed both of you this, or a Google sheet where I enter the scores every single day. And on the newsletter, you have this active collaboration rubric to understand what the numbers mean. You have this in your notebook so you know what the numbers mean. The person who talks the most learns the most. Plainly put. Because the person who's talking is the one who is engaging their brain. You gotta start talking. And I'm okay with you asking questions. Remember, one of the things during whole class discussions is ask questions. I'm hearing some people ask questions right now that I've never heard them ask a question before. If you have these questions now, you probably had the questions the first time around when I taught it. So then why didn't you ask the questions then, Gerald?
Because I'm not a pretty social person. I don't like to talk a lot. A lot of people don't talk a lot. That's why there's not a lot of collaboration in groups. I'm antisocial. I don't blame it. I talk to a lot of people myself.
Okay, here's the thing though. I hear what you're saying, but you've got to make a decision to overcome that for learning's sake and for working's sake. There are very, very few jobs that you're going to be able to pursue with the rest of your world where you don't have to interact with people. Part of this is the design of like trying to get you prepared for life after high school. I am hands down one of the most naturally introverted people you will ever meet. I didn't like to talk with people. I just liked to read when I was in elementary school and middle school. And what I realized was that, and this more happened in college, that I learned the best when I talk with people. So I'm going to push this to the forefront where you have to start talking with people. You say that you're antisocial, you don't like to talk. Well, unfortunately, that's not how life works. You got to learn how to talk with people. And when you start doing it, it makes it easier, it makes it better. But two, you're going to learn more, which is why I developed this active collaboration rubric. We may not like it, but again, this is something that I've thought through heavily and it's very good. You start talking more, you ask questions more, you're going to learn more. Okay? Even if you share your thoughts out loud, because I think this is what stems a lot of our issues, if we talk out loud and share thoughts, even if you get it wrong, you're still going to learn more and you're going to start to come out of your shell and you're going to be more okay every time you make a mistake. When I made mistakes, that's when I learned the most. When I struggled with things, that's when I learned the most. And that's why we have to share those thoughts out. If you don't talk, I can't tell that you've made mistakes or that you don't understand. If y'all haven't done the homework like the active collaborate, or not that, the graphic organizer, then I can't give you feedback to say, hey, this is how you improve your understanding. And every single person who turned in the graphic organizer, there's not just numbers on there, right? Look at it. There's a lot of words, right, where I wrote and gave you feedback to improve your understanding. If you're not doing the work I asked you to do, you're not going to grow and you're not going to learn. But I promise you, if you do what I ask, I've got you. You're going to learn, you're going to grow because I care about you. I don't just grade things and then give it back to you. It's feedback to improve your understanding. And trust me, that takes a lot of time. Okay? So, I know that we may not like it, but these are easy points if you're just taking the time to actively collaborate and discuss. Now, scoring rubric, really quickly. For those of y'all who got your graphic organizer back, remember you have a copy of this scoring rubric in your notebook. If you don't, let me know. It's a green sheet. Lime green sheet.
This pink.
Huh?
This pink.
The active collaboration was pink, I thought.
Oh, yeah.
The lime green one is our rubric for scoring.
Oh, yeah. I got one.
This will help you understand how I scored your graphic organizers a little bit better. Remember, the big things that we want to pay attention to is if you're in a 5.5 or a 6, automatically you show me clear, consistent, and convincing evidence of your conceptual and or procedural mastery. You understand what's going on. If you're at a 4.5 or a 5, there's clear evidence of conceptual understanding and or procedural fluency. That's where you want to be at least. If you're 3.5 or 4, you definitely need to reevaluate what you wrote there because there's limited evidence of your understanding. If you have a -1 to 3, I'm not saying that you don't understand, but what I'm telling you is I don't see the evidence of your understanding, which means you may need to go back and reflect on what you wrote there.
Mr. Kenny, how you be knowing we Googled it?
Bro, because which one are you looking at? Properties of equality?
Yeah.
And you talked about the reflexive and something else property?
We ain't talked about that yet.
And we never talked about it in class? Y'all, I know what I taught. Like, y'all writing properties down that, yes, are properties of equality that we never discussed.
But I
and aren't going to help you in these equations.
But it's like, you know that, though. It's like you know that those are properties of inequality. I thought you were just asking what's the property of it
But what's the point of these graphic organizers?
to help us in your classroom when we need it?
Yes, but it's not just that. How are you supposed to approach these graphic organizers? Notice we are supposed to first identify which lesson these concepts showed up in, right?
Right.
And I would include even problem numbers that they show up in. And then you're supposed to look at your notes and reflect upon your notes to figure out what to write down. Because when you reflect upon your notes, you're going to have to evaluate your understanding of things. And when you reflect upon your notes, you're also going to identify where you need to go to get the help you need when you approach these problems. And that was one detail I was going to talk about. It's very clear that a lot of us just wrote down what we thought we remembered. And what we thought we remembered, not 100% accurate. Or we Googled things that aren't really going to help us. The properties of equality that we discussed are whatever you do to one side of the equation, you do to the other side of the equation. By the way, I need you all to notice that language. Am I just saying what you do to one side, you do to the other?
No.
No. Because a lot of students mix that up and they try to do that with expressions. Properties of equality only work with
Equivalent.
equations.
Oh.
To create equivalent equations. You can also have equivalent expressions though. But what you do to one side of the equation, you do to the other side of the equation. That's a key thing that I use language on when we discuss this. And those properties of equality are creating equivalent equations so that we can find the solution. We got to know those things to the fullest degree. You will see on a lot of these that there's either a D with the number or a C. If it's a D, it's indicating that you're missing significant details or that you actually made an error with the concept that you wrote down. So look for those details so that you can improve this. Those graphic organizers, if you got feedback on it, you can turn it back in with the day we take the test, and I will reevaluate it, and you can earn a higher score. Yes, ma'am. Yes, I might have to print one out for you in a second. Okay. I think I ran out of those. But
You
again,
print me one out?
huh?
You print me one out too?
Sure.
Okay.
Okay.
Sounds like erasing.
Okay. What I would recommend is just write on a separate sheet of paper and add extra notes on there.
Okay.
Okay. So look for the detail. Are you missing details? Are you have a conceptual error? If you don't know how to add the correct details or fix the conceptual error, email me. Come into tutoring, do something. Watch the videos. Any questions about this at this point?
Mm-mm. There you go, computer.
Ready to get on the computer?
Yeah.
Ready to hear me stop talking? He's like, I can't say that, Mr. Kenny, but yes. All right. Look, guys, I know that this class is different. I get it. Everything I do is because I care about you. It's harder on me the way I teach as well. It's not just harder on you. It takes more effort and work on my part than what you may have seen in the past. But I know it's for your good, so I need y'all to follow the directions. And when you do, you'll grow and you'll learn. So, we're going to get onto the computers. We'll come back to that lesson tomorrow. So, one person per group. Go to